There are many applications of determinants. In the last episode, we saw how to calculate or how to solve simultaneous equations with two equations and two unknowns, or even three equations and three unknowns, using a determinant method, which we also called as Cramer's rule, to solve for x, y, and z. In today's episode, we are just going to use another application of determinants where we're going to find the area of a triangle when the given problem has given us the three vertices and their coordinates. So if such is the case, how you're going to find the area of a triangle? Typically, the elementary formula we know is area of a triangle is equal to half into base into height. But for that, the triangle has to be a right angle triangle. And then we know the base and we know the height and we compute that. That's one way of finding it. There's another geometric way of finding it, which I'm not going to get into the details in this episode. But determinant really comes handy when you need to find the area of a triangle, especially when all the x, y coordinates for all the 3 points are given to you like this. I put a sample problem. For example, let's say the question to you is find the area of triangle whose vertices are, and you've got all the 3 points given. And let's say this is the point A, this point B, and this point C. And you can assume that each one is a x and y coordinate, and you can calculate the determinant. And the way you do it is you just form a unique determinant like this, where the first column is all the x values over here. You write all the x values one below the other as column 1. Second column becomes y, all the y values. And the third column is just number 1. It's constant. It never changes for any of the triangle. It's 1, 1, 1. So again, the first column is all the x coordinate for all the 3 points given. The second column is all the y coordinate for all the 3 points given. And the third column is just a constant 1, 1, 1. You take the determinant of this number and multiply it by plus or minus half. And we'll discuss about what this means in a moment. So when you take the determinant of this number, right, you can take the determinant of this number and you might have a positive value, you might have a negative value, or you might have a 0, because we know how to find the determinant. And you can find the determinant using the determinant formula for a 3 by 3 matrix. You can pick up any row and any column, and you can do all the cofactor expansion that we just saw a couple of episodes ago, and you calculate the number. Okay, so you get a number which is a determinant which is positive, negative, or 0, because the determinant can take any of these values. Okay, but what we know is, okay, that determinant can be negative, yes, but we know that the area or length in terms of real geometry, that cannot be negative, right? You cannot have a negative area or negative length. You cannot say this length is -5. What does that mean? You don't know, right? So the length can be 0 or length can be 5. Similarly, area can be 0 or area can be 5 square units. But area cannot be negative. The geometry cannot be negative because you're measuring something and you cannot negative measure it. Okay, in terms of numericals you can do that, but in terms of area and length you cannot have a negative value. And that's where this plus or minus half comes into play to help you in a situation where when you find the determinant of this 3 by 3 matrix or a 3 by 3 determinant, and if the value for that comes as negative, then you can use the negative value over here, and since you're multiplying it as it shows as if it's plus or minus half multiplied. Basically, it means that you can take what it means is, let me write it over here. Just give me a second here. What primarily it means is whatever is the determinant of this particular 3 by 3 composition, you can either multiply it by plus 1/2 or you can multiply it by or negative half, based on whether the answer is positive or not. If the value of this whole number is positive, then you multiply by plus half into determinant, and the net answer will be positive because you don't want a negative answer. But for some reason, if the determinant is negative, but you don't want the area to be negative, in that case, you multiply it by negative half or negative 1/2, the negative over here, and the determinant is also negative here, and you get a positive value overall. So whatever you want to do to force the overall answer, which is the area positive, you use at your discretion, either multiplying it by plus 1 by 2 or minus 1 by 2. That's what the meaning of this plus and minus means. It does not mean that you use both the values. It does not mean that the answer is having two values. It does not mean that. The answer should be always taken positive because area is a real thing. And the plus or minus notation means use any of these signs forcing the final answer to be positive, whatever that is. And there is going to be only one answer. So do not get confused with the plus or minus prefix. There are no two answers. You cannot say the area is plus 5 and minus 5 square units. That's not true. Okay, the area cannot be negative and there's only one answer. It's going to be always plus 5 or whatever is the answer. So that's what it means. A quick wrap up on this video. Area of a triangle using determinants is given by this formula, where you put everything in a determinant format. The first column is all of x values, second is all of y values, third is the number 1. You take the determinant and multiply it either by plus half or minus half, whatever works, to make sure that the overall answer is positive. And whatever answer you get, that many square units is the area of your triangle. Thank you. I'll see you in the next video.